In today's video, we're going to explore momentum, which is a fundamental property that all moving objects possess. Momentum is a key concept in physics and helps us understand how objects behave when they move and interact with one another. The core idea to remember is that momentum is calculated by multiplying the mass of an object by its velocity. In other words, momentum equals mass times velocity. For example, if we consider a dinosaur with a mass of 4,500 kilograms moving at a speed of 12 meters per second, its momentum would be 4,500 multiplied by 12, which results in 54,000 kilogram meters per second. On the other hand, if we consider a car that has a mass of 1,200 kilograms and is traveling at 25 meters per second, its momentum would be 1,200 multiplied by 25, giving a value of 30,000 kilogram meters per second. It is very important to understand that momentum is a vector quantity, which means it has both a magnitude and a direction. This directional nature of momentum plays a crucial role in understanding interactions like collisions. For instance, if we define the forward direction as to the right, then a dinosaur moving to the right would have a positive momentum. However, if the car is moving to the left, its momentum would be considered negative. The next essential concept is the principle of conservation of momentum. This principle states that in a closed system where no external forces are acting, the total momentum before an event such as a collision is exactly the same as the total momentum after the event. To see this principle in action, let us imagine the dinosaur and the car as two particles moving towards each other and then colliding. After the collision, they continue moving together at a common velocity. To calculate that final shear velocity, we first need to determine the total momentum before the collision, which we do by adding the individual momentums of both the dinosaur and the car. The dinosaur's momentum is 54,000 and the car's momentum is negative 30,000, giving a total momentum of positive 24,000 kilogram meters per second. Because the momentum is conserved, we know that after the collision, the combined system must still have a momentum of positive 24,000. Since a positive value means movement to the right, we know the combined object formed by the dinosaur and the car will also move to the right. Since both objects stick together after the collision, we can now treat them as a single object with a total mass of 4,500 plus 1,200, which equals 5,700 kilograms. To find their shared velocity, we rearrange our momentum equation to say that velocity equals momentum divided by mass. We then divide 24,000 by 5,700, giving a velocity of approximately 4.4 meters per second to the right. So after the collision, the dinosaur and the car move together to the right at a velocity of 4.4 meters per second. In certain scenarios, the total momentum before an event might be zero, such as when objects are initially stationary. Since stationary objects have zero velocity, they also have zero momentum. In such cases, the total momentum after the event must also be zero. A good example of this is a gun before it is fired. Before firing, the gun and the bullet are stationary, so the total momentum is zero. However, once the bullet is fired and travels forward with a certain momentum, the gun must recoil backward with an equal and opposite momentum to ensure the total momentum remains zero. Let's look at a specific example. Suppose we have a gun with a mass of 2 kilograms and it fires a bullet with a mass of 5 grams, which is 0.005 kilograms, at a velocity of 120 meters per second. To find the velocity at which the gun recoils, we first calculate the momentum of the bullet by multiplying its mass by its velocity. So we do 0.005 multiplied by 120, which gives 0.6 kilogram meters per second. Next, we find the momentum of the gun, which will be its mass, which is 2, multiplied by an unknown velocity, which we will call v. Therefore, the gun's momentum is 2v. Now we apply the conservation of momentum by setting up an equation where the sum of the gun's and bullets' momentums equals 0. That means 2v plus 0.6 equals 0. Solving this equation, we subtract 0.6 from both sides, giving 2v equals negative 0.6. Dividing both sides by 2 gives v equals negative 0.3. This result tells us that the gun recoils at a velocity of 0.3 meters per second in the opposite direction to the bullet. The negative sign indicates that the direction is opposite to that of the bullet's motion. One final thing to mention is the notation for momentum. The standard symbol used to represent momentum is the letter P, even though there is also a Greek letter called rho that resembles it. The equation for momentum is commonly written as P equals mv, where P stands for momentum, m stands for mass, and v stands for velocity. That brings us to the end of this video. We hope you found it helpful and informative. If you did, please consider giving it a like and subscribing to our channel. We look forward to seeing you in the next video.